Sko, samtíð virkaði ekki.
Hæ?
Lene, ættu að tala þínu eigin frequency sem þetta sem að mækar getur í kallað.
Ég skil ekki hvað í gangi, sko. En þú veist, var ekki að stríma hljóðinu það?
Greinilega ekki. En samt ef þú segir eitthvað, sko, þá kemur þetta. En ég veit ekki af hverju hljóðið virkar ekki.
Rax, hvað þú segir það? En ef það er handskóli í kvarða, þú veist, 10. Skilsaflöfljóður. Nei, ok. Yes. Hvert er það að lögum mörgum 100 kallum?
Ekki bara sprakk. Það var bara...
Switch it up a bit.
Það var gott þarna.
En var þetta ekki hljóð? None of the time.
Hvað? Inga, viltu ekki?
Nei, við fengum við það.
Já, ok.
Get flott hjá.
Nei, við myndum bara að gera það.
Hæ? Já, endilega.
Greinilega var ekki hljóð á livestreaminu.
Já, hamborgarsmiðan. Var það aftur allt og mjög. Það er hundið. Ok, ég haf ekki. It works.
Takk maður.
Takk.
Hvað sagðirðu? Já, ég skal leita það fyrir ykkur.
Við verðum að fara að deyja.
Glaggi var bara í grænagrænum. Glaggi var bara í grænagrænum. Þá stendur ekki. Ég sá að svo grænagrænum var að fara niður og það. Saman heim.
Já, þetta er dokkaböndinu og...
Já.
Náðu að gera lífæðsæði, þú stæði á það 20 sekundar.
Við að setja
En það var samt líka á meðan þú varst að reyna, þá var Hlynur að reyna dyrfesta og var að blokka yfirtöðnum hérna. Já, ok.
Já, bara ekki.
En heldur ekki til lagað?
Það virkar núna.
Virkar núna? Það sagði í síðustu 2 skip.
Já, þú veist, núna heyri ég það í tölunni minni.
Ég var samt mynda að öskra á linjana með henni til skjöra sitt stefni. Það er alltaf hæggið. Síðan með loksins tókst það upplóta inn hérna minni eigin hörskildu á köfnum til skúr. Við erum bara að fá löst, en við erum löst á núna. Það bara geðveikt hérna. Geðveikt.
Ég var gæðið mikið hérna vingkast eins og vænta.
Já, því þessi á ég heila.
Það var hérna svo slæm var í bygg ofan á bygg. Það væri svona með vindfagn.
Já, þannig að Hilsifred kom og það var hérna svona ólega heilgja. Hilsifred, ég fann svona og við fórum ykkur svo landan. Ég fór reyna 20 sinni. Ég veit aldrei hvað. Ég var sagt, hvað gerir ég? Ég held eitthvað annað. Hann reynaði. Þú Hilsifred þetta? Þú Hilsifred þetta? Ólega heil. Ég er búin að reyna við þetta á 20 sinni. Sveita. Þannig að ég haldi á byggjum.
Ég heiti svona, ég heiti ekki kvöldur, ég það var ekki fyrir en ég fattaði þessi með mótvík sem var svo mittur, það var bara komið. Ég ætlaði bara að hann ekki í hönd á það, enda með svona töfur.
Varstu þannig framtekinn í huga þegar þú, nei, hérna, það séu, þegar þú sáði inn að þú fyrir að besta
Æslandir með samt að hafa aðeins fyrir eða hafa þeir
Þegar ég fór í dömur, þá var aftan að byggja bænir og svona lítið vextu. Það kom í stíli kerfi sko, bönnin eftir að ég klára það. Þú eftir, þessu þáttið það. Vistu þetta þessu núna? Ég stegur það. Ég komst ekki lengur. Ég ekki helmingina. Það byrjar með svo mikið. Ég er bara fucking useless. Ég er bara að skrifa þetta og það sækja mig út.
Það fáum maður mæsning og það fyrst sem verður að kjósa það er að það uppsett kostningu Þetta er svona snarlega köttur
Hverjir koma skúrum helgina? Ég var að gera svona fullt af fólki að segja það, ég kemst ekki þessa svo tímatík, hvaða helgin er það? Ég er tím ef þetta er annars öðru tím.
Ég samt að við forvitin hvað gerist.
Hvað?
Og så er det fra kullinnu og annars ingen kommer som
Já, við gerum þetta og svo þetta þá væntanlega þú.
Við erum svo eini sem bara bjóða
Og ég ætla að hætta.
Stakka betra því.
Ég ætla að hætta að screenshare þetta. Já, nei, ég ætla að screenshare en ég ætla ekki að...
Hello, 1, 2, 3, testing. Erum við hljóð núna?
En erum við mynd? Nei, erum ekki mynd. Show and broadcast. Ok, þarna kom. Hei. Já, refresha. Já, býta Ég er þinur.
Hvað?
Ég.
En samt ekki að það er ekki rétt hérna, það er gamalt.
Þetta er bara smá lag á því sem hann er að gera á tölvum sinni.
Eða?
Já. Þetta er YouTube-lag. Hann sagði hann svo.
Það sé líka með 20 mínúna sem ekki læga. Það er eins og þetta fólk getur séð Facebookið og
Já, hann er ekki alveg að respekta hverju.
Okay, so according to the poll, what, 21 people want to see how you solve pretty pixels?
Þetta er bara allt. Þetta er bara allt. Þetta er ekki vote. Þetta er bara allt saman.
What?
Það bara svona út af að þú vildi vera ekki alveg useless.
Lýsa öll dæmin. Við verðum inn í allt kvöld. Ó, já. Sleppum Hello World, þá spara eitthvað tíma. Já. En ok. Byrjum bara að leysa Pretty Pixels. Og ekki gera ennsku. Audio virka núna? Okay, so we're back. I think you didn't hear any audio in the stream earlier, so sorry about that. Okay, so first things first. Let's actually read the description of what is it called? Pretty Pixels. No, not Google. Pretty Pixels. Don't get me wrong, I love pretty colors as much as the next guy, but what does it mean? Okay. So we get this file, and it's just a bunch of random pixels. So let's just download the image so we can work with it. Okay, so we have the Pretty Pixels file, and if we take a look at the hex dump, we can't really see any useful information in here. Like, you would think that somehow this would like spell out some different form of file, but this just looks like a normal PNG file. So like the first step, should I make it bigger?
Nei, ekki þú.
Oh, getur þú gera þetta? Okay. Yeah.
Yeah, that's good. Keep going.
Okay. So what I would want to do is like, I assume these pixels have some sort of meaning. So what I'd like to do is write a Python script and actually just write out the actual data of the image. And we can do this fairly easily with a Python script using the PIL module. And I think I have a script here. So there's this neat function in PIL that is just called enter aðeins. Sérðu ekki línuna efst eða?
Nei, there you go.
Well, okay. So in the PIL image module, there's this neat function called 2bytes. So let's see what we get when we just pipe that into a file called ras.png. Ras.png. We see it's a PNG file. If we look at the hex dump of ras, we can see it's sort of funky. But it actually has like the PNG header and everything, and actually looks like a real PNG file. But like there's another solution like that is a little more intuitive, because like each of the like the RGB values in the file are like a single byte in another PNG file. So this image is actually the data of another PNG image. So it's sort of a meta image. So this is what a PNG file looks like. Hide the Hangouts, know this. Oh, it doesn't want to go away. Well, okay. But there's another more intuitive way of going about it, and that is, I don't have the script for it right now, but you actually would just do like, you would loop through each of the byte in the image. So you would do like I get what pixel, and I would do like XYZ, no XY, and then you would loop through just the height and the width of the picture. And for each pixel, just get the red, green, and blue value, and just push that out to some sort of file stream or something. And that would actually just, if you would look at the data, you could see like the first values were PNG. So then you would know that like something was up. But like getting to this conclusion, it takes some time, like actually knowing how to work with images in Python. It's very useful in CTF competitions. But I just like the simplicity of the script, just a single function in PIL. The goal was for you to find that. So, okay. Any questions about the problem? Was something not clear? Like, did I make any assumptions? I probably made some. Just raise your hand at any point if you. What? Okay. So we got this. Yeah, we got this res.png. It's a PNG file, and if we take a look at the file, we get a nope. Colors? You meant those things women and gays like? And you get the flag there. Put that in your coloring book and smoke it. Okay. I'm sorry. I like colors. Okay. And I think the next problem was aesthetic. You guys want me to do aesthetic? So this is another like image-related problem, if I can find it. We found this mysterious GIF. It's so beautiful, but can you restore it? So we get this GIF. Seems like a modern art piece. Now, how would we actually go about unscrambling that? Is someone in here that actually solved this? Ooh, okay. So the first step you need to do to actually solve this is to recognize what was actually happening to each of the frames in the GIF. And what is happening is it's being outputted through a filter called gmask. So you first have to recognize a gmask like thing, and usually this sort of stuff is used to censor, like, yeah, probably see. Okay, but okay. For example, you can just scramble like a couple of sections of the image, and there are actually recognizable patterns of these seemingly random things, and it's like filter. Can I get a list of? Because it's pretty simple to actually. Okay, so we just find a basic gmask tutorial. So here you get a list of all the filters that are available, and you can see what happens when you put each filter like on the image. So you just try to find something that looks similar to what you actually have here in the thing. So you'll notice is these blocks, and most of these blocks are 2 by 1. So you have these like most of them are connected to another block that is very similar, and we can find that here. So for this common mask, combination for this mask combination, watch out for both horizontal and vertical blocks of 2. This is a FL and MECO minus mask. So just by going through this GMask tutorial, we have found what mask they're using, or I'm using. But if we actually take this into like the GMask program, and like we can't just make GMask like so do it for every image. Like it's not programmable. It was made in 1998. Like this is really old. So you actually have to write your own script, or most people actually just found out that parts of the flags were on intervals. Like every 500 frames or so, I blinked the flag, or like the part of the flag. So most people just found those frames and went into GMask and unscrambled the frame. But I could not do that by making that GIF. Like I had to actually write a script that actually performed all the filtering. And I actually wrote a GMask, no, a GIMP plugin. This was fun. So I wrote a plugin in the Python foo API they have. And I should have that script somewhere here. This is stage 4, I think. Stego. Okay. Oh, and here's my write-up of the challenge. We'll release like the blog versions of the solutions hopefully soon. Not all of them, but hopefully some. So. So here we have a basic, like, I'll actually extract this. Okay, so we first have the basic overhead for a GIMP plugin. All this register bullshit, that's just in every GIMP plugin. But the juicy stuff is actually in here. No, not in here, in here. So it's actually just 1, 2, 3, 4, 5 lines. That's doing all the magic. Because like this is just like defining the function and then defining like a GIMP undo group. So if I press Ctrl+C in GIMP, it actually undoes the whole process and not just a single operation I did in the script. So it's not really part of the solution. But okay, let's see if we can actually run this into, let's see if I remember how to actually do this. Can I not just, did I actually install the thing here? If you haven't noticed by now, we're pretty much just winging this whole thing. So bear with us. If I imported it, I think it would go under animation. No, okay. So do you guys actually want me to import this GIMP plugin actually? Okay, so GIMP install Python plugin. I did this like 2 months ago, so, and I also format my laptop, so I don't have any other stuff.
When he explained this to me, I had no idea what he was talking about.
Yeah, so
I still don't.
So this was way harder than I had anticipated. Like only 7 or 8 people actually solved this, and I was surprised that it was solved within like 5 hours of being released or something, or like 10 hours. And both of the teams that solved it like the first were 2 Icelandic teams. I had no clue why. I was like, I'm sure they're cheating. Like, why are they solving this? So I actually sent them an email. I was sure they were cheating. So I sent them an email and asked for a write-up of the problem. And both of them said, "Oh, I remember this from some 4chan thread back in the day. Though everyone was using GMask, man." And like, I mean, yes, I got that idea for the problem when I was looking at 4chan and saw like this bunch of like scrambled stuff, and I was like, "Oh, this is perfect for a CTF problem." And I actually made a script that this did it for a GIF, but okay. So there's apparently a plugin folder here. And plugins. Okay, so I saved this to temp, I think. Temp. And let's, what did I call it? Let's call it like gmask.py or something. No. Okay, let's hope this works. If the name needs to be the same, fine. Let's just try it out. Okay, so if everything worked correctly, we should have a nothing. Great. What do I go into the console? Should I have like a browse feature? GIMP. I meant gmask. All right, so I actually, all right. So to actually use that, like, to make it such a simple script, I had to actually find like a GIMP, another GIMP plugin that was written in '99, I think. And finding this was insanely hard, so I don't know if I can find it now. But I think this, oh, it's right here, okay. When you've done it once, it's surprisingly easy. But I think I only need to copy this into the, hopefully I can put it in here. I'm just gonna give myself some time frame if I can't figure this out by like 5 minutes or less. Just move on to the next problem. But you can actually we'll actually release the whole write-up. So here I actually describe how I actually found this plugin, and yeah, I describe the script foo thing a bit, and I actually also say like how you inverse the functions. But I think I got the most the basic ideas out of the way. And also you guys can probably have fun with actually getting these exploits to work on your machines. So if you guys wanna learn something from this. But did I get it in here? Is going into the right thing? What if I go into this? Gmask. No, it's not even going here. What? Okay, I just need to put this into some global folder then. Whatever. You get the gist of it. Here's the script, and okay, let's just go through a script. And first thing I do, this challenge probably took me like 4 or 5 days to make, because I always kept hitting some dead ends. And first of all, finding the GIMP mask plugin thing took me 2 days, and then I kept getting into this problem of the script just failing when I started actually doing this image running the GIMP plugin thingy. And there is nearly no error output in the GIMP Python thingy, so I had nothing to work off. But I figured out that the image wasn't in RGB mode, So I first check if this is in RGB mode. If not, I do image convert RGB, and then I loop through each. I do image.layers to get each frame in the GIF, and just do 4L in image.layers. And then I do pdb.plugin GIMP mask, and then I pass in the image I'm working on, just the IMG I defined. Where was it? Yeah, it's just the current one I'm working on, passed through the function. And then there are IDs. So this is not really explained very well. So in the documentation, you'll see IDs for each filter. Like 0 is like a flip filter, and so, but the ID 1 is the Mako filter, and the ID 3 is the Mako filter, and ID 1 is the FL filter. And to actually like encode and decode the filters, they're like inverse functions and stuff. And if you want to do FL minus, this is currently FL plus. If you want to have FL minus, you flip this bit, and you get FL minus. Because like when you put the filter like FL plus, you need to get the original image. You need to do FL minus. So you just need to figure out like usually you figure out the filters just by solving one frame in Gmask, and then you have figured out the filters. You'll write the script, and then I just and it's finished. I just look through each of the images, each of the layers, and just apply these Gmask filters. But I apparently don't know how to install GIMP plugins, and I don't want to use the entire night to just installing GIMP plugins. So I think I'm just gonna pass it over to James to do probably some crypto. He always does crypto. James, what does the poll say? Sandcastles on the beach. Woo! Do you want me to do that, or?
Yes, you made it.
I mean, do you want to do some crypto first? Okay, sandcastles on the beach. Okay, by the way, just so you know, we're going through really obscure forensics problems at the moment. None of these are like Pwn or something. A lot of people find these sort of challenges annoying about capture flag competitions, but I love them, and I'm the only one who makes these forensics and Stego problems in the CTF. But sandcastles on the beach, I actually got the idea for that when I was reading up on Cicada 3301. I don't know, something like that. But it's like a really mysterious, like a hacker recruitment thing that happens like every year, I think. And they just make these insane challenges, give no hints. They just put up like a really obscure file that is somehow encrypted or something, and people are just are assumed to solve it somehow. And people that actually get through the whole trials, like no one knows what happens to them. Like some have speculated that they go work for some hacker organizations that is like multinational or something, but it's all just like theoretical, and no one really knows what actually happens. But I was reading through the challenge list of that competition, and they just have the weirdest challenges. And I found one that I really want to like put my own spin on, and sandcastles on the beach. So we get this mysterious image. It doesn't look complete, and there seems to be something hidden on it. Does this mean anything to you? Sandcastles.png. And we get this partial image. And I think if we just copy the image address, go to Google, go to images, upload file, and do URL. We should get something. Okay, so we get Cryptography and Network Security by William Stallings, 4th edition. So, so we have some book, I presume. If we go into all, I think we can get some PDFs, but okay. We also need to extract some more info from this image. where did it go? I didn't download it. Okay. If I do EXIF tool, Sandcastle. Okay, we see this comment right here. And it is like 579 210 something. It looks really weird, so let's bring that up to Vim. And this seems to be like in these groups of 3. So let's actually just, actually I can do some magic, I think. Place the dots with like a new line or something. Not a comma, what the fuck? No. Why the fuck does it mess the whole thing? Music. James, get on the music. I need to escape the dot. Oh, it doesn't want to recognize the whatever. So we have these groups of 3. So if we have a book and these like numbers that are like grouped in pairs of 3, like it could be something like a book cipher, if I can spell it correctly. But okay, a book cipher is a cipher in which the key is some aspect of a book or other piece of text. And let's try to find some examples of that.
Which was national treasure.
Did they actually use it?
Yeah.
Oh, neat. So if you want to learn more about book ciphers, what's national treasure? Anyway, now that we know what book ciphers are, so so these are actually like coordinates to page numbers, line numbers, and word numbers. So if we actually just get the PDF, did I lose it?
What's the key?
What was the key? What do you mean? What key? Hold on, I'm trying to find the book. Well, if you look into the description, you see there's this random number here. This is actually a hint. This is the MD5 sum of the PDF you were supposed to use. So yeah. So let's see if we can. Actually, I probably have it.
Ég vissi alltaf að byrja á því ég vissi hvað fyrst það eru. Var það ekki
Starling's cryptographer. Okay, MD5 sum. Okay, we see that this Starling cryptography thing has the sum of 10331, and we see it's the same as here. So apparently this is the correct PDF. So do I have some PDF viewer? Okay, so I can't see my screen now. Okay, wait. Yep, it had the same MD5 sum. But if we go into, where did I have the numbers? 58. Okay, so let's go to page 58. And by the way, at least 4 teams actually bought this book. So I was really impressed, but you don't need the actual hard copy to solve this problem, and because you need the actual PDF page numbers, not the actual page numbers. So people were going to page 58 in the physical book, and there weren't enough lines in the in the pages, and they were like really confused and were whining about it on IRC. So, are we on page 58 now? Okay. I'm just gonna see like show like a couple of numbers, or one number maybe. So 58, 7. So 1, 2, 3, 4, 5, 6, 7, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first word is not. And when you go through these, you'll get like 11 words or something. And that's actually where a lot of people stopped, because when you actually got the words, it didn't make any sense. It was just random words. So I can maybe find the word somewhere. No, whatever. But you would actually need to extract the first letter of each of those words to actually get a message that makes sense. So a lot of people like stopped at that step where they just got the words and they were like, oh no, I'm obviously doing something wrong. I'm just gonna bail. But I actually gave people hints. If they gave me all the words, I would tell them there's only one step missing, and told them they were on the right track. But a lot of people just bailed at that point. But yeah, but this is an actual problem from Cicada 3301.
Can I just show, because this is what I have a screen share now. Oh, screen sharing. Yep.
But let's try to get into some more actual exploits, rather than just obscure forensics.
So this is the IRC chat, while everybody is listening to him solve it, and they're telling him how much they hate him. And
Really? Thanks, guys.
I hate you for Sandcastle.
So a lot of people did not like Sandcastle, just because it was really obscure, but...
That's why it wasn't working.
That's why it wasn't working, okay. But yeah, a lot of people just gave up on that point, but this is like actual... when they solved this in the Cicada challenges, they got no hints. Like, they didn't even get like the... I gave like the correct PDF thing and everything, but they didn't get anything. Like, and they somehow solved it. I don't know how I did it, but okay. James, do you want to do some crypto? Let's see what is up in the... Next is Slick server. So, are you doing that? Beautiful. So Slicker server, it was a problem made by Ymir. It was a web server written in assembly, and so obviously it was very unstable, kept crashing, obviously. But we can unfortunately not show you the solution because he's not here, and we actually...
No, he's on.
He's on?
Yep.
Can you actually show us the solution? That would be awesome.
Hello.
Yay.
Ymir, can you show us your screen?
I can. Greetings, everyone. Okay, let's see.
Can you turn him up?
Turn me up, please.
Ymir, can you turn up your mic?
Yes.
Please do.
Let's see. One man, one way. Greetings. How is this?
Yeah, just turn down the music.
Yeah,
Okay. So we have this interesting problem over here, which is an HTTP server that's coded in assembly because some people have too much free time. So this is something we adopted from the internet. The intent with Slicker server is that you would find that this was ASMTTPD that somebody had created. But it's a reasonably sized.
What?
She's dead.
Ymir, are you there? Ymir, you died. Can we still see a screen though?
Yep.
If you are alive, please type something in the terminal. We're sending help. Maybe Google Hangouts was written in assembly and it's just crashing. He has probably just finished this explanation by now. Can you like message him or something?
No.
Wait, have you muted me so he can't hear me? Oh yeah.
He left.
Did he leave? Do you want to take Attack of the Hellmen? Just real quick. Also, the next in line is round Rapids if you want to do that instead, or first or whatever.
He's back.
And that's how you solve. And that's how you solve Slicker server. Sorry, guys. Oh yeah, I have no idea what happened here, but the wired connection died. Okay, anyway, so let's just do this quickly here. What am I sharing quickly? Can you guys see me type on the screen over here? Everybody cool? Can you see me? La 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 la. No? Hear no sound.
No.
You can't see anything. Okay. Let's see if I can just do a screen share of a single window then. Terminal. How about this one? Hello, can you see me?
Yep.
Oh, okay, let's do this. So, yeah, as I was saying, somebody decided to make an assembly-based HTTP server, so of course that's perfect for one of these competitions. Let me actually take the Slicker one over here. So we decided to add a few things to it and not give you the source code because that's the kind of people we are. And so what we ended up with is this tiny little server. It's written in assembly, and what's unusual about it is that it maintains its own kind of stack.
Where you died.
I die. Hello.
Again.
Greetings.
Tell me his mic is out.
Test. Hello. Testing. Hello. 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 Can you hear me now? Yeah, who are you? Okay, heyri ekkert í mér. Testing.
Við erum smá í þér.
Já, við erum smá.
I will scream.
Það er næs.
Hello?
Hello.
Greetings. Okay, let's try this out here. Microphone. Hey, actually, let me try a different microphone here.
Það hljómaði svo mækinn sé bara eitthvað smá pluggað út. Þegar bara eitthvað hægra megin og eitthvað.
Nei, þannig að svo lappa í burtu frá mæknum svona slowly á meðan hann að leysa dæmi.
I'm just gonna leave it right here. Okay, so.
Hello. Different. Can let me know if anything here is changing. I'll just speak in voices. Can anybody hear me?
Sort of.
Anybody hear me?
Move closer.
Hear me? I'm eating the mic! I am eating the
mic. So Emil, listen to me carefully.
Test.
You're going to plug your mic out of the port and plug it back in.
All right.
Can you read me?
I can read you. Testing. Okay, how about this?
Oh shit! Abandoned ship! Abandoned ship! Are we back? Are we dead?
I'm here.
Okay.
Can you hear me?
Let's try this again from the top.
Okay. Anyone can hear me? Yes. Does
Loud
it sound
and clear.
okay?
Now we're
Sound
good.
okay? Hello?
Yes.
Is the sound okay? Is the sound okay?
It sounds fine. Just continue.
Will do. Thank you. Yes. So we have this beautiful assembly program over here, which has its own stack layout. And the whole intent with this thing was to create an overflow that didn't use anything that you normally use for overflows. So what happens is that this thing here will kind of casually read in a buffer to something that's too small. So it will read in like what's here a thread buffer size, which is about 1,500 bytes, and it will overflow this debugging hook over here that I'm highlighting. This debugging hook, instead of it just being something like a return address, it does something a little bit more. It's being very annoying. In fact, what it does is that it sees before it accepts a request whether or not the debugging hook is null. If it is not null, which would only happen when you overflow something, you're going to call an HMAC. So you're going to take effectively the hash of your buffer, and you're going to take that hash and jump to that address. So in other words, in this exercise, you actually have to not just create exploit code, but the hash of your exploit code has to be a return address. So that's insane, right? Now, first when we did this, I had it so that you could XOR something with your return address, and then it becomes a lot easier. You can bypass all of it. So that's the difference between Slick Server and Slicker Server. So Slicker Server, it's very annoying. So here, for instance, in Slicker Server, it moves this thing to
It's going so well. Ymir, ertu hana?
Nope, he's dead.
Well. Okay, so we're just gonna bring a random person from the audience to finish the problem. Pop quiz. Should we just come back to this, or?
I really don't know.
Well then. Já, sem sagt, hassa-exploituninni þarf að vera þetta.
Hann gerði einhverja algjöra síru og ég hef enga hugmynd hvað hann gerði það hvernig.
Enginn veit hvað hann gerði, nei.
Já.
Og svo var hann líka í einhverjum pælingum með sko að hafa, hann kominn aftur? Já, hann var í einhverjum pælingum með að hafa eitthvað svona drop chain sem að væri ekki svona alveg augljóst hvað væri, þannig að þú þarfst að nota eitthvað svona constraint solver til þess að ná að finna rétt á drop chainið. We're back.
So, I had a fantastic explanation. Everybody's listening so well, and of course, you know. Anyway, anybody want to hear this stuff?
Please continue.
I have 5 minutes anyway, so I'm just going to do it really quick.
Okay.
So we have this assembly server. There are two problems with it. There's two things that make it hard. One of them is that the return address has to be the hash of your input buffer. So in other words, you need to really reverse that input buffer to be able to match that hash. So in the first version, Slick Server, you could actually XOR something with it, which made it simpler. So a lot of people are able to solve it as a consequence. In the Slicker server, you don't have that. You have to actually be able to use your murmur hash. So that brings us to the constraint solver that Lynn was just mentioning. The second thing is that if you look at Rock Gadget over here, you actually have almost nothing to work with. If you look at these things, this is all just complete junk. The only...
We can't see your screen, Ymir.
It's not my day, is it? Okay, how about now? Look,
Yep.
This is Rock Gadget over here, okay? And if you just look through the gadgets that we have here, this is all just complete junk. The only thing that's useful here is one deliberately planted chain here, which is this one over here, this address. So this means that you have to go through a very elaborate collection of things that we added to the program called funny names like Reykjavik and duplicity. And then, of course, Sindis is hiring. Scott and Floyd. Trump is even here. Yeah, if something fails, you go to Trump. It's just something that interrupts your program. So you have to kind of look and read through these things and be able to understand, like, oh no, I have to know exactly what the base pointer would be, and it gets XORed with RDX, which is something under your control. So you have to make sure that these things match, otherwise Caligula eats you. So you have to make a really explicit ROP chain. Now, in order to be able to solve the first part, which is the constraint solver, the solution is going to look something like this. So this is the XSplit over here. So just like to show you some of the mechanics that we're working with here. This is something just to read from a binary the exact location of a symbol. So knowing exactly where Sindis is hiring, or where Reykjavik, or where a particular system call is issued. And then what we have here is a part of what's called the Z3 constraint solver. So now we're going a little bit elaborate, which is what makes this problem hard. We're actually going to ask a computer to say, give me what input I would need in order to be able to make it hash to this return address. What do? Well, you take the hashing algorithm that's inside the program, and you code it up here in Python, except in using regular variables, you use this special thing called bitVec, or whatever it needs, whatever. So here's, for instance, this is the entire hashing function. Now we can ask the hashing function, which is here doing a full HMAC. We can ask it, hey, I need to find these variables over here, and I need to find the key so that these things hold true, so that it matches my return address and also the XOR of the matches a checksum. And this takes about 20 minutes, which is absolutely insane. Like if you were to get 128 bits, I mean, you would be going until the end of the universe, right? If you were to just naively try to brute force these values. Instead, what Z3 does is that it figures out that this hashing function here, the murmur has, is pretty bad. It's not very, doesn't mix a lot. And so it's able to find a good solution. So what we feed into these routines is then the actual ROP chain, which, as you can see, is a little bit long. So we have to, like, there's a system call here for doing dup2, because you're trying to maintain the connection and duplicate your file descriptors. You have your popret and pop-up-ret and so forth for picking up the different variables. This is all 64-bit. And here's your checksum that you need for things to be matched. And then you assemble things. As you can see, I may have tried it a few times. And so the comment, the option really looks like as the following. You need to do called dup2, and dup2 is so equipped that it needs to match a certain particular checksum. You load in AX, you need to match some sort of weird other type of checksum. You get your popret. Here's something to match a different thing. There's a lot of little things you have to worry about. Now, what is nice here is that it's 64 bits and it's written in assembly, so there's nothing that stops you from reading in a null byte. So you can just enter null bytes. You don't have to worry about that here. And then finally, we end up with a system call over here, which is the kind of 64-bit equivalent of interrupt 80 or OX80. And then there's a padding thing to fill up the buffer. And at the end here, we put the output of the solver itself, which is the extra things that are required to make it hash to what it needs to be. And that's it. So if I actually run this thing, it'll just start running like this. It'll take about 20 minutes. But if I take the output of it, exploit, so I think I ran it for 15.3 times, I can netcode that to slick.IceCTF 46601, and I should get a shell once every like 3 tries. Yeah, because the stack is a little bit unstable. So as you can see, I now have a shell, and then I can. Oh, I'm not going to show you the flag. Okay. Sounds good.
Yep.
Cool.
Awesome.
And by the way, Let's give a round of applause to Cleaner, James, and Helacat for putting on this competition. I think they did all the work. They deserve the credit. There we go. Okay, I'm popping off now. Good luck, guys.
Thanks, man.
Thanks.
Okay, so now James for some crypto.
Yay. So, which ones? Oh, okay. I'm going to show you Attack of the Hellman, and it is going to absolutely. Hang on. So, I had the idea for this problem by this paper, which came out, which was on how the NSA would theoretically have. Fuck. Okay. So how the NSA would theoretically do an attack on Diffie-Hellman, which is Diffie-Hellman key exchange is how you communicate securely with websites. So usually it's a big part of it. So if you can attack that, then you can essentially decrypt all the connections, and like, for example, if you're connecting to your bank, then someone standing in the middle could just get all your credit card information or whatever. So yeah, it's a bad thing that to find attacks in that. What is going on? I don't know what's going on. But no, it's not. What? It's not. Ja. Og gjør showen. Nei, sett den. Ja. Ja. Thank you.
Velkommen. Bare på deg.
Ja.
Ja.
Ja. Struttler sitt. Ja.
Vi erum núna bara að sína lausnir, erum bara að hakka á sviðinu núna.
Já, þú má fá í pítsu.
Það eru fyrir pítsjörina.
Já, við erum eiginlega búinir að gefa verðlaun. Kannski, en ég veit ég alveg. Jú, þeir eru þarna, einhverjir alveg.
Þú getur tekið mynd af vinningsliði.
Þannig og... Já.
Hún var að klárast, já. Þetta var tveggja með kemni, sko. En þetta er bara síðasta wrap-up eventið.
Já. Viljið þið mynd af ykkur? Hvað?
Með byggarinn, má ekki glemma því. Ok, bara halda verðum að leysa dæmið og...
Já.
Það eru cool skilti hérna og eitthvað?
Já.
Þetta ekki verið með? Nei.
Ráðu bara upp fyrir mig aðeins og...
Bara dragu?
Þetta er myndaðið hérna.
Find the room. Já. So sorry about that. A reporter just came in. For those people watching. So yeah, the paper behind this problem was sort of how the NSA would theoretically have backdoored Diffie-Hellman, and I made sort of a challenge based on what I understood from that. And so what you do is, what you get the public exchange parameters, and you get an encrypted flag, so which was encrypted using the key, the exchange with Diffie-Hellman. So maybe first we can look at how Diffie-Hellman works, and then I can explain the attack. So there's a good, yeah, hold on. So essentially, Diffie-Hellman works that you choose a prime and you choose an exponent. And yeah, this is actually a very good thing. So you choose a prime and an exponent, that's this paint, the common paint. And then I choose one color and then Bob chooses another color and I mix it with the common ones, with the common color. And then I send the mixed thing over to the other one, and then we mix it. I mix it with my color again, the one that I got. So I got blue paint from Bob, and I mix it with my thing, so I got brown paint. And Bob got well, orange paint from me, and mixes it with blue paint, and he gets brown. So we end up both with the same key, but over the given the information that you have, which is only this yellow paint and this paint and this paint, you can't get, like, you don't know what to mix it with to get to the brown one. So, and this is a very hard mathematical problem, which hasn't been solved yet, although it's going to break if we get quantum computers, but whatever. So yeah, there's a problem based on this. So okay, so yeah, this is P. It's just a giant prime, and this is G. So those were in that picture, those were the yellow colors, and then A is this paint, and then B is the other one, and so on. So you just get this, and we gave essentially no hints to mess with people, but yeah, so you get this, and you're sort of like, okay, what do I do with this? There's an attack which is called so in mathematics, this problem is called the discrete logarithm problem. So what we're actually sending is I chose a number G. I chose a number A, and I send G to the power of A modulo P. So the mathematical problem is called, so like if I were just sending G to the power of A, then you would take the logarithm of base G of the number that I sent, and you get A. But it turns out you can't do this in any group. So if you could take the discrete logarithm of this, then that's equivalent to getting the secret colors here. So if you can solve that problem on A, so that means if I get this color here, and I take the discrete logarithm of it, and then I could get the secret paint. So that's essentially how you would attack it, and this is one of the, like, there aren't many attacks on Diffie-Hellman, but this is one of the few attacks. So now you have to try, you have to, of course, do research, and there are a couple algorithms to do this. So in general, they're, what was it called again? Logarithm. Yeah. Here you go. So yeah, there are tons of algorithms to do this. None of them work fast enough, really. So, for example, if you take Polik-Hellman, that I'm not going to explain the basically Polik-Hellman, but what we care about is that it runs in blah 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 the square root of p. So in other words, given this large p, it's roughly going to run in the time of a number half that size, which is still going to be, I don't know, a number this big. So that's how long it's going to take with that algorithm. So how do we solve this? Yeah, so if you look at all of these algorithms, there's one here, which is this one, which runs in a bit better time. It runs in O of the square root of b minus a. So what is b and what is a? This algorithm will try to find the discrete logarithm of a range. So sort of assume that I know that that the number which was chosen is between, let's say, 0 and 10. Then, so if I know, well, let's say 0 and, I don't know, 10 million for the sake of, because you can just brute force 10. But let's say you know that, then you can run this algorithm, and then A is the small, like the lower end of the range, and B is the larger end. So then this algorithm would run in O of B minus A, which is 10 million, sorry, the square root of 10 million, which isn't that bad compared to whatever large number this is. So the idea is, like, A wasn't chosen that badly, but the problem is that G is a generator of a small subgroup. So what that means is that, how do I explain that? Essentially that this common paint, no matter how you mix it, you can only get roughly, if I remember correctly, about 10 billion different possibilities, different colors, in other words. So the result here will only be about 10 billion different colors. So that means that we can use this attack because we know that roughly that we can use this algorithm because we know that so we know that roughly A is between 0 and 10 billion, and the square root of 10 billion is only about 100,000 or something. So, and of course this information wasn't given, but the idea behind the problem was that you had to try this. So you had to guess, essentially, okay, it's probably small, so let's try 10. Let's try a billion, let's try 10 billion, let's try 100 billion, and so on. And this is an example of a practical attack. But now to solve this, and this is going to really mess with some people. So if I just start with Sage, and then discrete log. So this algorithm is a function in Sage. So essentially, once you get the idea of how to solve it, you just could do this. Yep, A, comma, G, comma, P. What was the? Oh, right. I'll have to do G. So we have to set it up into the group, which was and then this thing broke. Okay. Discrete log lambda A, comma G, comma 0, comma 10 to the power of 10. And now we wait, and there's your solution. And then you do the exact same thing for B, G of B. And there you go. And now you know what the secret colors are, and you just continue on with the problem. We gave some scripts to how you convert this into the key that was used to encrypt, and you're done. Wasn't that fun?
Any questions?
Yeah. Does everybody understand? There were some actually really cool solutions. Like I'm not even sure if I'm not sure how many people solved it like this, but someone managed to sort of do this by partially factoring p-1, which took him some time, and then what do you do again? Then it turns out that Polig-Hellman, the algorithm I showed, it can be simplified vastly if you know some of the factors. And then and then someone managed to do this by, what do you do again? He took, this Pollard row and then just left it overnight or something. Which in my opinion shouldn't be allowed, but yeah, I guess it's something that happens when you have a 2-week CTF. You do technically have 2 weeks to do this. So, but yep,
So
that's how it was.
would you guys like to see some more crypto or some web? Steve, what was the Steve problem?
Steve is playing it again.
Oh yeah.
So more crypto.
That was almost the same thing as last year. So last year we had essentially this problem where you got the RSA keys, and where you got an RSA key and you could just run what's called a Wiener attack on it, and it would just factor the key. Yeah, does everyone know how RSA works? I assume so, since you did.
Solve the RSA problem.
I tried to make sure you guys, but whatever. So yeah, and his key was here. So here's his blah blah key, his public key, and yeah. But this time I changed it so that you can't actually run that Wiener attack on it. So it's almost the same problem, but so hold on. Just to explain this, so this is a Wiener attack, how to do that, but this is the important bit. It only works when d is less than 1/3 times n times the 4th root of n. So what I did this time was I made sure that d was just slightly larger than that. And how do you solve it? So it turns out that at least RSA is thought to be insecure. What was it? Up to if d is ever smaller than the square root of n, and there's an algorithm which will work up until, what was it again? 0.29 times n or something like that, times the root of n. And that algorithm is called the bone. So this is an attack which is an extension of the Wiener attack, which does exactly the same thing, except this one works for slightly larger d's. And yeah, I'll just show you because I had to implement this. Where is it? Test. Yeah, but yeah. So yeah, here's you use the what's it called? Yeah. You use the guy provides an implementation here, so I just use that. And you can extract the public. You can extract the public key, and from the from this thing on Gist, and plug it in here. You have to tune the parameters a bit, but that's how I got this to work, and then I was happy. So you just run this, and it is going to take a little bit of time, but that is the lattice, if anyone understands that. of the attack, but it's relevant. The attack works. So, and when it takes about 5 minutes to finish, or I'm not sure. Yeah, it did take some time to finish, but it finds the exponent, and then you just take that and combine it into the key, and yeah, you're done. So yeah, the last ones were mostly finding attacks on the crypto without really information about how you attack the crypto. So we didn't give out what the weaknesses were. And the thing is, these weaknesses can actually exist in the wild. Like, this is both problems are something which actually very likely is happening. So like the first one was, that's exactly how the NSA might be doing this to everyone, actually. Like, given their access, they could definitely do something like that. They'd probably make it a little bit harder, which the paper which I read shows. You can look it up if you want. Yeah, this thing is broken. Það var endur á öllum skólanum. But I can assure you that this will finish soon enough. And yep. Oh yeah, there it finished. And there's your D, and that's just your secret. Yeah, and that's your secret key. So now you just plug this in, which is so this takes the key pairs and makes it into a PAM file. So count RSA. That's what you get from that, and then as RSA Steve at shell. And there you go. Done.
Okay, so is there some problem you would like to GeoCities. GeoCities. Okay.
Yes, GeoCities. So that one was the shell shock vulnerability, which was what really big last year.
So essentially, we wrote this as a website in Bash.
Yeah, which was very good of him. I'm very proud of how he. So yeah, we'll just. Oh yeah.
Did you fara á síðan og lesa description of them?
Nei.
Það bara exploit þessu og þá með bara frá heim.
Yeah. Let's go. Yeah, so we can do the test shell shock thing, which is just if we get X. Hold up, what?
Það gæti verið ávart gett og saftur.
Finnur, ég lemdi. Fokka þér, farðu heim. Út veg. Nei, út.
Lokka þig inn á mainframe, látt ekki svona. Eða.
Já.
Á ég útskýra propositionið þitt bara.
Já.
Meðan. Fullkomin logíkum af allt.
Já.
Þetta var planað.
Ég veit hvað ég gera. Takk. Þrjú.
Ok. Á meðan að James afpannar HR af blokklistunum okkar. Ég bara útskýra dæmið.
Víst!
Finnur, nei.
Nei, ég var ekki bara topp umsættu, hvað sem er?
Halló, ok.
Þess aftur á pinnu.
So, I actually have this. I should have this somewhere here. So, I need to stream my thing. Okay. So you got this website. Why are you not? Okay, so we have this website. Actually, let's read the description. What was it again? Geocities. But okay. I recently stumbled upon this old GeoCities site. It's a miracle that it's still up. It must be running on some ancient technology and probably hasn't been updated in years. It's our lucky day, boys. Okay, so let's go back to the website. Where was it? Okay, so you're greeted with this hopefully not familiar look, because this is horrible. But if you didn't know, like most of the websites back in the 90s looked like this. And I tried to encapsulate all of the latest trends back then. For example, the dancing baby, and like the Etsy flaming GIF, and all of those websites back in the day had this warning label: "This site is currently under construction," because people were lazy back then. And apparently this justified it. But I don't have the proper blog posts. What did you do? Okay. On the actual site, we're currently blocked from it, so I can't see it. But on the actual site, there were actually real blog posts. And it was like a storyline from a system administrator who wanted to make a blog or something. And he counted up all of his favorite technologies. Oh, I just learned Bash, and I'm really enjoying MySQL and something. And so we try to like drop hints on what technology was being used. So the guy was actually describing like how he likes automating tasks with Perl and stuff. So the first thing you need to realize, like, it was written like way back in the day, and so you could try a couple of different things, like trying to exploit the CGI thing, like Flinder did, like CGI bin some stuff. Didn't quite work, but if you know it's running Bash, and it was hinted in the description, it hasn't been updated in a while, so the shell shock vulnerability is probably still there. So if you just pass it through the user agent, the shell shock, or is it some environment variable, then you can just execute some arbitrary code, like a reverse shell. Just get a shell on that box. And when you get to that point, there's no flag. You can't see any flag.txt, and a bunch of people messaged me saying like, "Oh, the challenge is broken. I can't see a flag.txt." And then I asked them, "Do you leave a password.txt on your desktop?" And they were like, "No." And I asked them, "Well, like, why would I leave just flags hanging around on the server?" So it was like not anywhere on the file system, but it was actually hidden on a secret table on the database. And do you have the thing working?
Yeah, but it's. Oh, we forgot to.
Just switch it over. Okay. Did you unban the IP? Oh, you did. Okay. So if you actually read the posts, you can see like there's some storyline in here. And like you see, as a system administrator, he works on Unix machines. And I love Bash and Perl. They're incredibly powerful tools which make my life so much easier. Then he goes on to talk about MySQL. And yeah. So from here, you would just need to try out a bunch of vulnerabilities, like the CGI ones I mentioned, or just the shell shock. And do you have the exploit running?
No. Hold on.
What are you doing? Okay.
No, what's the
Ekki máli. Takk fyrir að koma. And also, I'd like to mention who solved root of all evil here? Only you? Okay. So, I made this forensics problem. Oh, það skiptir ekki máli. Ég get að sé síðan sjálfur. It was a forensics problem which had like a couple different steps. You got like a file system from like some guy, and you need to find like a hidden base 64 thing in a binary. And if you took the binary, no, the base 64, converted it to like a WAV file, it sounded like some dual tone multi-frequency thing, like old phones used to use. So if you run the WAV file through like a DTMF, what's it called, some decoder, you would actually get like a couple of numbers. These numbers didn't make much sense. It was like, I can probably find it somewhere. And we got so many tickets about this because you'll see why in a second. No. This one. Okay. So you just got these numbers. But it actually was more like looked more like this. No, this. So this doesn't make much sense, and people were just thinking like this was the flag or something, and we're just submitting that. But these are actually, if you do this, you get GPS coordinates to Iceland. So if you go to Google Maps, not Google APIs, and let's see where this leads. Couldn't find, should I have like dots? Virkar ekki screensharing hjá mér?
Nei.
Actually, það perfect, þá get ég sýnt myndina sem við fengum.
Nei, byrju.
Okay, so this is just outside the school. It's between RU and Perlan. And this is just like in the middle of the forest. And it was really well hidden on like some tree. Was it obvious for you guys to find it? Did you have to walk around or something? Okay. I wasn't sure how accurate the GPS was, but okay. And didn't you guys go into some adventure or something? Yeah. Okay. So first, when I released the challenge, I didn't realize I chopped half of the audio signal of the WAV file. Like when I was trying to like doing something with it, I just chopped the half of it off. I don't know why, but it had like what was it? It was like this for like 10 hours. And where is this? Somewhere near Rauðavatn eða eitthvað. Or what? Yeah, so somewhere just okay. And they apparently went there. So I took them on an adventure and a half. But then and our auto editing for the problems broke. Like we had some formatting issues. What? Nei, það er alltaf leið.